Namaste, welcome to Papa's Physics. Now we are going to discuss about if you are changing the medium between the two charges, what will happen. That means, suppose to be, you can understand very simply, this is the one charge, that is the Q. Right? This is the charge which creates the electric field in the space. Now, if I introduce something around this one, there is one medium is there. This is a one medium. In general, as of my explanation previously, this is a one charge. Supposed to be this is a 1 coulomb of charge. It is in between these two. I introduce the medium. That medium of dielectric constant is the K. According to other formula, F is equal to 1 by 4 pi epsilon naught. This is K times into capital Q divided by R square. This distance is R. This time the Q is equal to 1 coulomb charge. That's why F is equal to 1 by 4 pi epsilon naught Q by R square. This is nothing but electric field. Force experienced by the unit positive charge is called the electric field. Force, that is why I written that electric field E is equal to F by Q. It means that force per unit charge, force per unit positive charge is called the electric field. So force per electric field in the sense, suppose in between these two I introduce the electric some other medium. That medium of dielectric constant is K. Now new electric field, here K epsilon naught I am going to write it down. See, if I am changing the electric field, if I am changing the medium between the charges, automatically force is also changes. The new electric field E is equal to 1 by 4 pi epsilon naught into K into Q by R square into R cap, where R cap is called the unit vector. Now R, electric field E bar is equal to 1 by 4 pi epsilon Q by R square into R cap. It means that if you compare these two, epsilon by epsilon naught is equal to K. Epsilon is nothing but the permittivity of the new medium. Epsilon naught is space. Permittivity of the medium with respect to space is called the relative permittivity. It is also called as dielectric constant. Then epsilon is equal to K into epsilon naught. You substitute here, you will get this is. If you are changing the if you are changing the medium between these two, then there is a changes takes place in electric field. Suppose electric field in the space, that means in between these two nothing medium is there. That time electric field is equal to 1 by 4 pi epsilon naught Q by R square. If there is no medium, simply you can write air. If something is introduced, 1 by 4 pi epsilon naught into K Q by R square. From these two, we are going to conclude that E by E naught. What is E by E naught? If E by E naught in the sense, this is becoming R you will do one thing. This is becoming 1 by K. This divided by this. K. Right? 1 minute. Okay. 1 by K. That is E is equal to E naught by K. The meaning of this one is, if there is a space between the two charges, electric field strength is more. If you are introducing any medium, that medium of dielectric constant is K. The new electric field of strength is reduced by K times. Do you understand here? The one and only the difference between these two is E naught is the space of air. In the air, 1 by 4 by epsilon naught Q by R square in the air. If you are introduce the media between these two, E is equal to 1 by 4 by epsilon naught K, where K is the dielectric constant, Q by R square. Here you need to remember all times you are not changing the distance, you are not changing the origin of the charge, origin of the electric field, but you are changing only the medium between the charges. Then 1 by 4 by epsilon naught k q by r square. Then E by E naught, this divided by this, you are going to get 1 by k. 1 by k, then E is equal to E naught by k. If you introduce any dielectric medium, the electric field is reduced by k times. That is the concept of this one. So from this, first if there is a electric field due to the space, it is E naught. If you are introducing any other medium, the electric field strength is decreased by k naught, where k is electric field strength is decreases by k times, where k is called the dielectric medium of the inserted medium. So from this we are going to conclude that even the medium between the charges is influenced by the strength of the electric field. If you change the medium, electric field strength is also changes. If you are keeping the constant the medium, it is also remains the constant. But k is nothing but relative permittivity or dielectric constant. It depends, it can change from medium to medium. For dielectric constant there is no units. That is the conclusion of this. Now we are going to discuss about the null point or neutral point. Null point means 0. The effect of electric field at which is 0, that point is called the null point. Supposed to be these are the 2 points. These are the 1 point charge. This is also another point charge. The distance between these 2 charges is the r. At a distance of, this is the supposed to be, if I assume to be positive charge, even this is also positive charge. Due to this charge, electric field direction, this is, let it be E2. Due to this charge, electric field direction, this is, let it be E1. At this point, at a distance of x from the Q1, electric field is 0, that is E. So the remaining distance from this is r minus x. Now we are going to calculate the r value, x value, sorry. X is the distance from the Q1 charge. In that one, electric field due to E1 bar plus E2 bar is equal to 0. Total electric field at the point P is equal to 0. So if I am going to say this is 0, as per the definition of electric field, 1 by 4 by epsilon naught, this is Q1. E1 electric field positive direction supposed to, Q1 divided by at point x square, plus this is opposite direction, 1 by 4 by epsilon naught, Q2 divided by the distance is r minus x whole square. This is negative, opposite in direction, so I am going to write minus. Total is equal to 0. Because both are, one is acting, this is supposed to be positive x-axis, this is a negative x-axis, that is what acted to negative of this is. Or if you wish, you can write it also, no issue. Negative of that. From these two, the common point is 1 by 4 by epsilon naught is the common point, Q1 divided by x square minus Q2 divided by r minus x whole square is equal to 0. So from this, Q1 divided by x square minus Q2 divided by r minus x whole square is equal to 0. I am sending back to that side, Q1 divided by x square is equal to Q2 divided by r minus x whole square. I am taking square of both sides, r minus x divided by x whole square is equal to Q2 divided by Q1. From this, I am sending this square to that side, r minus x divided by x is equal to root of Q2 by Q1. Do you understand this one? There are two charges are there, Q1 is one charge, Q2 is another charge. This is supposed to be, I am assuming that these two charges are the positive charges. Now the distance between these two charges is r, then at a distance of x from the Q1, point P, electric field strength is 0 because we are calculating this. This is positive charge away Q2, this is negative charge, this is also positive away this. Q1 is positive and Q2 is negative x-axis. So minus r 1 by 4 by epsilon naught Q2 by r minus x whole square is distance. So this is the called the principle of superposition. This is principle of superposition. Now 1 by 4 by epsilon is common and Q1 by x square minus Q2 by r minus x whole square is equal to 0. This part not equal to 0 but this part is equal to 0. So from this one Q1 divided by x square minus Q2 divided by r minus x whole square is equal to 0. Q1 I said to that side, Q1 by x square is equal to Q2 by r minus x whole square. Then I am sending to this side r minus x by x whole square is equal to Q2 by Q1. R minus x divided by x is equal to root of Q2 by Q1. So now from that one r minus x divided by x is equal to root of Q2 divided by Q1. R by x minus 1 is equal to root of Q2 by Q1. So r by x is equal to root of Q2 by Q1 plus 1. I need x. So x is equal to r divided by root of Q2 by Q1 plus 1. The common formula for this one, x is equal to r divided by root of Q2 by Q1 plus r minus 1. If I use the plus symbol for similar charges, similar charges in the sense both may be positive, both may be negative. Negative sign for dissimilar. This is for dissimilar charges. So this is about the formula to find out the null point due to the 2-point charges. Okay. So simply we can calculate the null point from this one. And this is the null point x is equal to r divided by where r is the distance between the two charges, root of Q2 by Q1 plus r minus 1. This is, you have to remember that this is the formula from Q1 charge. From the Q1 charge. Don't, if it, that is a Q1 charge all times. So this is the formula which is used to find out the neutral or the null points. There are two charges are there. One charge of magnitude is Q2 is equal to 4 coulombs. Q1 is equal to 1 coulomb of charge. This is the Q2 charge. This is Q1 charge. These two are separated by a distance of 9 meters. Q1 is, this is 1, this is the 2, this one are 1 coulomb, this is 4 coulombs of charge. Q2 is equal to 4 coulomb, Q1 is equal to 1 coulomb of charge, distance r is equal to 9 meters. Null point supposed to be, this is the null point from Q1 charge, then x is equal to r divided by root of Q2 by Q1 plus 1 because this is positive, even this is also positive. That is why from this x is equal to 9 divided by root of 4 by 1 plus 1. That is 9 divided by root of 4 plus 1 in the sense 2 plus 1 is equal to 2 plus 1 3, 9 by 3 is equal to 3 meters. At a distance of 3 meters from the Q1 you will get the charge. You will get the null point supposed to. Same, Q2 is minus 4 coulomb, Q1 is 1 coulomb of charge. Where you are going to get the field? X is equal to r divided by root of Q2 by Q1 minus 1 because negative charges. R, that means 9 divided by root of Q2 means 4 by 1 minus 1. We are going to get 9 divided by 2 minus 1 is equal to 9 meters. At a distance of 9 meters, you may get a doubt. how it is 9 meters, sir? Because at a distance of 9 meters, that you can understand. Suppose to be this is a 1, Q2 is a positive 1, this is Q1 is a negative 1. The distance between these two is R. At some point, else you do another thing. Now, Q1 is positive and Q2 is negative. So, at a distance of X from Q1, that means out of, because the direction of electric field due to this one is E2, due to this one this is. So these two fields are going to be cancelled at a distance of this out of these two. That is why X is equal to 9 meters, where Q2 root of Q2 by Q1 minus 1, Q2 is 4, 4 by 1, root 4 is 2, 2 minus 1, 9 meters to the distance, where you are going to get electric field is 0. That means out of these two, why? Because of those two are the one is positive, other one is the negative charge. So that is why we are from Q1 charge. That is why we are explaining X is equal to R divided by root of Q2 by Q1 plus or minus 1 from Q1. From Q1 in the sense, from Q1 distance, those two are the similar charges. It means maybe positive charges or maybe negative charges. Then if those two charges are the positive charges, you have to take the positive sign. If those two charges are the negative charges, you should take the positive charge. If those two, one is positive, other is the negative, and vice versa, you should take the negative sign. That is about the